Yes, dear viewers, Teacher Ambrose, Riverflow International. Today we are going to see or to share how simple machines simplify work. Normally, for us in primary 7, we talk about the simple machines, and the simple machines we talk about, they are grouped into 6 groups. So with me here today, I want to talk about the pulley. How does a pulley as a simple machine simplify work? So we all know we have different types of pulleys. We have the single fixed pulley. We have the single movable pulley. Then we have the block and tackle system of pulley. Now, we are going to see how all of those pulleys help simplify work. What are we beginning with today? We are going to talk about the single movable pulley. How does it simplify work? So, to begin with, we want to see how a single movable pulley can simplify work. With me, I have my pulley, a stand or the complete pulley here with me. Then I have the movable pulley, the one that will be moving with the load. You see, it moves very well. It's a movable pulley. That's why you say a movable pulley. Then I have the load. This is the effort we are to overcome, and this is my load. Now, before we do the load or we start the activity, we need to first know how heavy is the load. This is why I have what we call a spring balance. In other words, these are some of the materials I am going to use in carrying out activity of how a single fixed pulley simplifies the work. So, to begin with, you get your spring balance. You get your spring balance. Then you first measure the load. And if you could observe very well, grams, if you could observe very well, you see it has the scale of 25. So this one is 40. It has 40 grams. This mass of mine has 40 grams. So when you are lifting the mass using the spring balance, no any machine, it has 40 grams. Now we want to see if I am lifting it using a single movable pulley, what energy do I need? We all know that the single movable pulley has the mechanical advantage of 2. Having it the mechanical advantage of 2, it means that we need a half the load to lift it. In other words, the effort we need should be a half the load. Let us try and see whether really we need a half of the load to lift it. Here, as I've earlier said, I get my movable pulley. Then I will hook it in the load. And this is our load, as we have said. It's down here. Then our thread, make sure our thread passes through the groove of the pulley, as you can see mine. What are we going to do to have the exact and know whether what we are doing is correct? We are going to use the spring balance as we earlier did. We want to see, is it true? Do we need a half of the effort to lift the load? And you don't count when the load has reached in the atmosphere. Once you lift the load directly from the ground, you count from there. So my cameraman, you can come here and zoom, and you see the effort we need. And you see the effort we need right away from the ground. If I lift from the ground, just lifting from the ground, you can see the load I need is almost 20. 20 is just up. So when you look at the load, it's almost 20 grams. Meaning that indeed we need a half. We need a half of the load to lift it, or we need a half effort to lift it. To lift the load. This is simply how a single movable pulley works and how it simplifies the work. So following the steps I have followed, teachers, let me hope you are going to follow the very same steps, and we show our learners how a single movable pulley simplifies work. Teacher Ambrose, Riverflow.